a ruler.
I hate it. No.
It's not a ruler.
All right, folks.
Seriously.
Amazing as that was, it's going to get a little more amazinger.
It feels so good. It looks so awesome when it's pink. But it's better when it's green.
All right, I have drawn an angle. I haven't measured the angle. I don't know what its measure is in degrees. It's just an angle. I want to make a copy of the angle, just like I made a copy of the line segment. I want a copy of the angle. And because the sides of the angle are raised, how long are they?
Infinite.
Infinite.
Half of infinity.
Not half of infinity. They're infinite.
Okay.
Okay.
How long is half of infinity?
It's twice as long as a quarter of infinity.
500 is infinity.
I was saying.
Don't ask me embarrassing questions.
Like what? What was the embarrassing question?
So when I make a copy of the angle, I don't need to worry about the length that I've drawn that ray, because it's just there to symbolize something that's infinitely long. I don't care about the length of this. What I care about is the angle. So I'm going to get the ball rolling here by drawing. This is similar to what I did with the line segment. I'm going to draw one side of my copy. So there's a ray. That's going to be one side of my copy. What do you suppose I would need to do to make a copy of that angle? Good start. So, oh yeah. Look, it's just like an angle, right? This should be easy.
Oh my god.
What do you think?
Perfect.
You're saying to yourself, gosh, you know, I've never seen anybody do that before. No, I'm actually joking. That is not a great idea.
Are you serious? You actually wrote that down?
Yeah, you have to take everything I say with a grain of salt now, don't you?
Yeah.
I'm sorry. All right. Maybe I could do something like this. No.
Yes.
Oh.
Well, why not?
Why don't you just do this? I got an idea.
Josh,
I have.
we'll get to you, JJ. Josh.
You follow that first line, get the second line, and then you find the angle between the difference.
Oh.
So you have to find the bottom line distance. Then you draw the line, the bottom line distance with the compass, and then you find the distance between the mouth, the two ends.
You still want to use the ends here somehow?
Yeah.
Oh.
Well, so the problem with the ends is that they really are what I'm trying to copy. JJ.
You could start. Okay, so.
She wants to go up to the board.
Okay. Yeah.
When she stands up,
And she can actually use the paper here.
Okay.
Yeah, you
So-
step aside.
That's cool. So you start here, and you can measure like that, right?
Okay.
And then you go here, and then you can go like that, and wherever. Oh, that wouldn't work. Never mind.
Down. Down.
I think you can go in there.
Yeah.
I'm going to go out on a limb with JJ, and we'll do that.
You just have to figure out
And then you measure the distance between the two intersections.
So what have I done here? I've got an arc that's the same radius as this arc.
Wait.
Abby?
Put the end of your compass where the bottom arc where it intercepts with it, and then line it up, or make it the same size.
To go to the other
Yeah.
intersect? Like
and
this?
Then go, yeah, and then go down to the bottom one. And
No, but you would have to.
No, you can do that.
yeah.
Does that solve our problem?
And then draw the line.
Draw the line through it. Okay, let's try that.
Maybe sit down. Sit down. What if you just put one end of the compass on
Hey, Kyle. Kyle. Got it. Andrew.
just one end of the compass on the vertex where the two rays meet?
Yeah, over here.
No, the one, yeah, and then stretch it all the way out, like open it up to the end of that one,
Mhm.
and then go back and to the no, take that same measurement and put it there. Yeah. Oh wait, never mind.
Ah, okay. You know,
I don't know.
you don't want to use anything that depends on this arrowhead because that's really not a fixed thing. This method works, but I think what you're describing, Andrew, is also going down a reasonable path. You could make a matching mark here and here, and then do a matching mark here and here. And in fact,
That means the lines are equal then.
well, I mean, I made a mark here. I've already got the side in place, so I know where to put that. But really what I've just done here is the same thing. Because I could continue this arc and make it a complete arc. And I could have made this a complete arc. And in fact, what I think you're getting at is the fact that when I do this arc here first time, I don't have to do a full arc. What I'm really interested in is where that crosses here and here. And I'm defining a fixed distance from the vertex of the angle to here that I can duplicate over here. I'm really duplicating a segment. This segment gets duplicated here. This segment gets duplicated here. So I'm building a triangle, actually, that's the same in both cases. So you can imagine, you know, I could put in this third side. What I've really done is I've copied a triangle. Same thing. Now, I could also have made a copy of this distance here and then used a shorter distance on this side and done that kind of thing. It's just really easy to make both of these arcs, both of these crossings, the same distance from the vertex. You have one compass setting. So again, you start out by making an arc here or a couple of crossings. Don't change the compass. Come down here, make a big arc, measure the distance from side to side where it crosses that arc, and then make a corresponding mark here, and that defines the second side. So I've kind of made this drawing a little bit busy by playing with it, so it's a little confusing. At this point, though, what I'd like you to do is the same thing. You should draw, if you haven't already, an angle using a straight edge, and see if you can make a copy of it. And if you've got a protractor, you can kind of verify your work and see, did I actually do it? So I'll try that now. This looks like a copy which is 46 degrees, and my original was, looks like 45 degrees. And my experience with quick constructions like this is you can get accuracy, repeatability to about a degree. It's typical if you're careful.
But exactly are the steps again? Which one do
You know what? Let's go through it again because this is getting a little bit busy. So, and one thing I wanted to say about tonight's homework. There's a lot of questions on tonight's homework where you're asked to copy something from the book or work with a drawing that's in the book, measure something that's in the book. And if you're doing this with the online textbook, that's a real pain in the butt because you get these little holes in your computer monitor. And then, you know, your folks get angry, and then I get phone calls, and it's not pretty. So what you can do is if there's a thing in the textbook where it says copy an angle, just draw a copy first and then copy your drawing. So you can make up your own problems. And then I don't get yelled at. So there's almost no reason why you can't do all these questions from the online textbook. Don't come in and say I couldn't do it because it was on my computer screen. So there's the angle I'm copying. I've set my compass. This setting doesn't matter. It could be small, it could be large. The larger you make it, the more accurate it's likely to be. Now I'll do two little crossings here. And I just have to make sure I keep the same length. I'm going to do it an angle like that. So somewhere out here is going to be my... And measure this. and then bring it down here. So I have changed my compass setting to do this. This arc is much smaller than the original arc, but this distance now matches this distance. The final step. So this is a construction. I would like you to do it in this way. We are going to do some constructions later on in the chapter where you can get creative. And I ask people to come up with their own ideas.
Now the real question would be if those two lines are parallel, would that angle be the same as the other two?
Would it? So if this was parallel to that,
Oh yeah.
would this angle be parallel to or congruent to what? This one?
Or any of them.
Any of them. Well, what do you think?
That one.
This one? Okay, what are these two angles called?
Opposites, same.
It's in,
Transverse.
This is a transversal.
Oh no.
Oh, they're the.
opposite.
Wait.
Exterior angles.
Hmm.
Interior, opposite, exterior.
You're throwing some words at me.
Remember.
They haven't
Angles.
stuck yet.
Wait, they're corresponding angles.
Nope.
What are you looking for?
Wait, how did you
This
get
one
the
and this
longer
one.
arc?
Oh,
They're interior.
alternate interior angles.
Awesome, Ethan. Alternate interior angles.
Oh, we already said that.
Oh, I didn't hear you.
No,
Ah,
it's a
okay.
corresponding digit.
I heard it was
I didn't say it,
corresponding.
but someone else did.
Okay.
I know somebody else did.
Hey, you know what? Kian. So you mentioned that as a transversal of two parallel lines. Did it ever occur to you that might be a good way to make parallel lines?
No.
Hmm. No, it didn't occur to me.
Graph paper.
Something to think about.
Yeah, you gotta drink water.
All right, so you guys, you got about 5 minutes. I'd like you to start tonight's homework. So get your textbook out, use your compass, and start working.
We have homework?
Homework? Yes, for a 3-day weekend. You bet you do.